Hi guys. Okay, so the first thing we're going to do is we're going to solve systems of equations. And we're going to do that by graphing. So we're going to graph the systems of equation. And this is the first of three methods. So it's the first of three methods we're going to use. Okay, so now there's three steps to solving by graphing. The first step is to get both equations. So get both equations into slope-intercept form. So we want both equations in slope-intercept. Okay, if you don't remember what slope-intercept form is, that is y equals mx plus b. So we want both equations in this form. Okay, our next step is to simply graph both lines. So we're going to graph both of these lines on the same point, on the same graph. Okay, because we're going to want to find where they intersect. So that's our last step, is to find the intersection point. So we're going to find T-E-R-S-E-C-T, find the intersection point. So we're going to find where these two cross. And this is going to be my answer then. Okay, so here are our three steps. We're going to get both equations in slope-intercept form. We're going to graph both of the lines, and then we're going to find the intersection. Okay, so after we do that, the answer is going to be written as an ordered pair. So we want to write the answer as an ordered pair. So remember, that's x comma y. You may be wondering, how many points do I need to graph? Okay, so that's a great question. You're going to want to graph as many as possible. As many as possible. So you want to graph the entire way. So as many as possible. As many as you can. Because you don't know where the lines are going to intersect at, or what quadrant, or anything like that. So you need to make sure you graph as many as possible, so that way you cover the entire expanse of it. Okay, and again, the intersection point, that's where they cross. Okay, where the lines cross. And that's going to be our answer. All right, so let's get started and look at problem number 1. All right, so we're going to want to look at this problem. The first thing we're going to want to do is graph them in different colors, I would say, and you're going to need a ruler. So you're going to want to do 2 different colors and a ruler. Okay, so we're going to graph this first one in red. So just to remind ourselves, we want to start with our y-intercept of plus 3. And then we're going to want to go our slope, which, in case you forgot, is 1 over 1. So go up 1 over 1, up 1 over 1. Again, we want to draw as many points as possible on this line, extend it as far as possible. Okay. And then you're going to want to take your ruler and draw this line. So that way it's as accurate as possible. You want to maintain accuracy here. Okay, so we're going to draw our second line that also starts at plus 3. And then it goes up 1 over 1, up 1 over 1. But this time, because it's negative, it's going to the left. So really similar equations, but not quite the same. Okay, so I'm going to draw my line. And the whole point is to find the intersection point. And I'm pretty sure we did that. And the intersection point is right here. It's right here, this dot. And that is the ordered pair 0, 3. So since this dot is the ordered pair 0, 3, that's where they intersect. That's going to be our answer. Okay, so hopefully that's pretty okay. So we just graphed both lines, found their intersection point. So we're going to do one more together. Okay, so let's look at example 2. Checking, are they both in slope-intercept form? Yes and yes. All right, so we're going to graph them different colors. Okay, find where they intersect. So I'm going to start with this first one. I'm going to go down to 6. Okay, and I'm going to go up 3 over 1, up 3 over 1, up 3 over 1, And again, at least for the first line, you want to draw as many as possible. It's not as important for the second line because you could see where the second line really crosses or where it's kind of going. So since my graph's going this way, I'm only going to draw a little bit of it because I don't really care about the rest of it. So then we see where they intersect, and they intersect right there at this point right here. Okay, again, accuracy, my line wasn't very accurate, so it kind of made it a little hard to tell exactly where it was, but the point should be 3, 3. So the answer then is 3, 3, and we write it as an ordered pair. All right, so let's look at the next one then, example number 3. All right, so looking at example 3, if the lines are the same, how many solutions will I have? So if we have 2 of the exact same lines, we're going to have infinite solutions because they're obviously going to be graphed over each other because they're the same exact line. So if I'm graphing 2 lines over top of each other, they're going to have infinite solutions. So if the lines are the same, they'll have infinite solutions. If my lines never cross, then they're going to have no solutions. So if they never cross, there's going to be no solutions. Okay, so let's do one more example here. So the first thing we need to do is to get both equations into slope-intercept form because they're not. So I'm going to start with this 5x plus 3 guy. So I know it's 3y equals negative 5x plus 9. I just moved my 5 over. Then I'm going to divide both sides by 3. Okay, so y is going to be negative 5/3 x plus 3. So now we can graph that guy really quick. So let's graph him. So I go up plus 3, negative 5/3, up 5 over 3, down 5, 3, 4, 5, over 3, down 1, 2, 3. So down 5, 1, 2, 3, 4, 5, over 3, 2, 3, 4, 5, over 3. So just be really careful that you're going over the right distances. It's really easy to get that mixed up, and then your lines won't really cross. So you just have to be really, really careful about that. All right, let's solve this other equation, the yellow one. So moving my 2x over, so we get negative 3y equals negative 2x plus 12. Divide both sides by negative 3. You get y equals now a positive 2/3 x and a minus 4. So again, for this one, we at least just have to do a couple. So be really careful with these negatives down here because they're a little off. So we got to go up 2 over 3, up 2 over 3. I'm just going to do a couple, not the whole way, because I can see where they cross. And they cross right here at the point 3, negative 2. So again, be really careful. So it's it's positive 3, negative 2. Okay? So now I want you to try examples 4 and 5 on your own. And keep in mind, after this, you're going to want to do the homework. Okay? And the homework is 4 problems out of the textbook. You can check that on the Canvas page.